linked list, stakes, and queues within the data structure. So first of all, the linked list. Every item in a linked list has a pointer. The pointer points to the next entry within the list. A pointer is known as a terminator, which represents the end of the list. This means that the data does not have to be stored in a block, but can be scattered pretty much all over the place, maybe. It also allows the data, but not the actual structure itself, to be changed after the structure is created. So to sum this up, the use is that it holds data in an ordered manner. A feature is that it can insert and remove any item or node from the list. The pointers, every node has a pointer located to the next node. Then the last pointer has a null point. An advantage is that it is the most flexible type of linear list. The disadvantage though is that it is complicated maintenance of pointer. So if you want to read either the start or the first item or node, so it's complicated to maintain where the pointer is and stuff. Right, so a stack is known for the last in, first out, so the LIFO data structure. It means that the most recent piece of data that was placed onto the stack is the first piece to be taken off so it can be executed. Alright, so when you want to add data to a stack, you need to check to see if the stack is full. Then if it is full, you need to report an error, and then it reports an error and then it stops. If it is not full, then the pointer is incremented, and then the data is added at the location of the pointer. When you want to remove data from the stack, so when you want to pop data off the stack, you need to check to see if the stack is empty, report an error, and then it reports an error and then stops. You need to, but if it is not empty, then it outputs the data where the stack pointer is located, and then it decrements the stack pointer. So to sum this up, it is used, so it's widely used to control program execution of subroutines. So the feature of this is that it is last in, first out, so only the last item is accessible to the programmer or the actual program itself. Then the pointers that are used are that there's only one pointer used called the stack pointer. It locates the last item in the stack. An advantage of using a stack is that it is easy to ensure that the items are removed or read in reverse order. And the disadvantage is though that you can have the stack overflow and the stack underflow, which can cause the program to crash. Now there's queues. So another thing is that there are queues. So the queue is a first in, first out. So someone comes here. Since I was first here, I'll leave. So is a first in, first out, which means that the most recent piece of data to be placed in the queue is the last piece taken out. So think of a queue like you find at a supermarket, the first person in the queue is the first person to be served. First in, first out is actually also is an example where it's actually used is in a printer, since you don't exactly want it to be all messed up with the data that gets sent to it. So when you want to add data to a queue, you need to check to see if the queue is full. Then you need to if it is full, you need to report it reports an error, and so it reports an error if it's full. If it is not full, then it moves the end pointer to point to the next piece of data. It then inserts a new piece of data at the end of the queue. When you want to remove a piece of data, you need to check. Well, it checks to see if the queue is empty. If it is empty, then it reports an error. If it is not empty, then it removes the data which is pointed to by the front pointer. it then moves the front pointer to the next item. So to sum this up, the use is anywhere resources have to be shared, such as the print queue as I just said. Now the features are that is the first in, first out, so there are actually 2 pointers within this, so there's the one located in the front of the queue, and then another located in the back of the queue. So the front points in, this is the data you need to use next, and then the one at the back is saying, this is the free space. Now, the advantage of using a queue is that it's easy to ensure that the items are removed or read in the order that they are entered. But then a disadvantage is that not as flexible as a general list, as only the front of the queue can be read. Alright then, so there's a sub queue, so it's like the circular queue or buffer. It is used by passing data from one process to another. It is the same as a normal queue, however, so there are 2 pointers still used, but then the advantage is that the size of the buffer should be well defined at the design stage, so there can be a set for the maximum memory efficiently when moving data from one process to another. Disadvantages though that the buffer can underflow when it's empty, so it can cause problems. To avoid this, the read and write process has to be carefully managed. So a circular queue is just one that goes around in a circle. Then another thing is the binary tree, but I'll get to that in the next video.